What do I start with? I start with a point. So I go to my geometry and I just want to locate this point somewhere. At the moment, this point doesn't exist. I need to give it a parameter. I double click on my canvas, X, Y, Z, and I get all these options. I need a vector to tell this battery where to place the point. And at the moment, if you stick a panel in, sometimes if you don't exactly know what you get out, stick a panel in. And if you zoom in, this panel produces 3 points in 0, 0, and 0. X, Y, Z, 0, right? So if I stick this into my battery, you see a little change. Perhaps I need to focus here a little bit that you can see. It's annoying that I can't make this window bigger. So please keep an eye on this one here as well. Yeah. So if I click onto this point, you see this point here in your Grasshopper, in your Rhino environment turns green. Yeah. So this is how these two correlate. Okay. I could, for example, if I double click on my canvas and I give it a slider, I can move this point. Yeah. At the moment, we move it in the x-axis. If I stick, I right-click, I disconnect it. I stick it, let's say, in the x and z axis. I can use the slider in all directions, but here you see the point is moving both in the y and the z direction. Yeah? But we're not using this at the moment, just to give you an example. So this is our starting point. We designed everything from the 0, 0, 0 position. Okay, and now I need, it's I think under the curve tab, I need a rectangle. I tried this out yesterday with boxes and stuff, but this is, for me, there are various ways, and perhaps you can try to figure out how to do it differently, because there are probably 20 different ways to do it. But I choose a rectangle. Yeah, and the rectangle needs various inputs. It needs a plane, and this point comes. Hold on, I need to zoom in a little bit more. This plane shall be my one wall. This is one of the walls. Should I do? Yes, let's start with the walls. So this should be my first wall in X direction. So I give it the material thickness, and I could use either a slider. It's a bit difficult when you work in this mode here. Hold on, I need to switch this off because I can't see my parameters here. I need to do this slightly differently. Perhaps I can, yeah, should be able to do this slightly better. Okay, here we go. And I give this in the y direction, so I want this to be the green wall here, right? So I stick in a slider, let's make it 50 mm, and I stick this in the Y slider. And here you see I get a rectangle, but it's just an outline of a rectangle. So this is a curve, polycurve, right? We want to turn this into a surface we can extrude. You know this already from previous exercises. And for this, we go to the surface params and go, this is a very useful battery. It says boundary from surfaces. At a boundary surface, it creates a surface from a boundary curve. And here, we have a surface now, right? So we leave this for now and do the intersection in the X variety. And I do exactly the same. Let's put this out of the way. And I'm just going to show you what you can do is you just highlight the batteries you need, and you just copy C, copy V. You double this up. So you have the same, but you want it in the Y direction. So we disconnect this one, and we stick this one. We want to have it in the X direction, right? And now, we move this, and this has an automatically probably set 10, -2, -2. We also want to give this a thickness, and here we use a panel. Oh, this is really annoying, noise outside. So I want to give this a material thickness of 3. Right? Again, I use another panel, double click it. So, let's give this something roughly 100. Oh, this is 100. So we've got 2 base walls, one in Y direction and one in X direction. Both are 3 millimeters thick, right? And now, how do I move them? The first thing is, I think the next thing is what I'm going to do is I'm going to make the ground plane. So again, I use a rectangle, double click and rectangle. And I give this the same location as I have given the others. We all start from the same corner. And now I take the X and the Y. I take the X from here with the Y from here. And now I have my ground plane in the same size as my walls. I also need to make it into a surface. So whenever I change the parameters here, all parameters change. Okay? Let's quickly save this. So I want to concentrate on just working on the floor here, on your ground plane, on the bottom of your cabinet or whatever it is. And I want to give it an extrusion. So this is a straight extrusion. You can get other extrusions where you go at an angle. But the battery still remains with a warning signal. It needs a direction. It needs a Z direction because we go upwards. And I want to fix, whenever you are sure you are sure about a parameter, like the thickness of your cutting material, yeah, use a panel rather than a slider. Double click, clicking through, and don't press return. You just type in 3 and that's it. Don't press return. So we have already our ground plane. Okay. Now, I want to move the side walls and extrude them. And I was playing around with this yesterday, and I did the move first. So on these, let's hide these ones. Let's concentrate on the side walls. So before I extrude them, I want to move them into the right position. So let's look at the wall in the Y direction. And we want to have also, you remember, we want them overlapping for later doing the intersecting areas. Yeah, so that's quite important. So I want to move. Type in move, and it's this battery. Move. I have it differently here. This is X, this is Y. So this is, oh no, this is, so basically this is the Y. I want to copy and paste this basically onto the other side. What I do is I just move this here. Whenever you move an object, the original data remains, is still there. Yeah? So it doesn't mean it disappears. So I move this surface to this end here, right? But at the moment, it has a built-in 0, 0, 10. At the moment, it's moved into the Z direction, but we want to go into the X direction. So I double-click X, unit X, return. And now, we need this length. And we do not type in the length, we take it from here. And now you see a problem arising. We want these two areas to overlap because later on we need to subtract the thickness to get the interlock, right? So there's a little bit of a tricky thing here, yeah? So at the moment, you have, I moved, hold on. I moved this one in X direction to here. We want to achieve the same overlap on this corner. At the moment we haven't got it. So we need to take off the material thickness. And we do this with a little mathematical equation. So we just take 3 millimeters off. So how do we do this? We can do a simple subtraction. Double click subtraction. We probably have to go into math. Here. Basically this is a simple A minus B. Yeah? A very simple operation. So we stick the X, and we can take the 3 from here. We can either take a new panel. So at the moment, this doesn't change anything, but we want to take 3 off. So we can take the 3 from here, and then we get the overlap, right? So that's already looking good. And now we do the same for the Y section. So here we move this one, and we move it in the Y direction. Yeah. And we want to move it into the Y direction, which is here. Yeah. And again, you see we don't get the overlap. So we need to do the subtraction again. So we just take the minus. So it's basically in the Math tab, you get all sorts of mathematical operations, from simple additions and multiplications to also scripting. So we make a simple subtraction. We take the, where was it again? The X minus 3, and now we get the overlap. Okay, here. That's exactly what we want. And now we need to funnel all this data. We merge the data to bring the whole thing together. So we take our first data and our second data, so these are the moved parts, yeah? As you can see, if I click onto these ones, these are the moved parts. But I also want to use the original parts. So here, and here you can see if you merge data, it automatically increases. So here this is basically just a data assembly point, yeah? So, and now here we've got all our 4 walls, or the basis of our 4 walls. And what we want to do is we want to extrude it. And obviously we want to extrude it into the Z direction. And here we can use a fixed panel if we know, but we can also do a slider. And bang, we have our 4 walls. Right? And we can hide this for now and go back to our ground plane. And you remember, it's quite good to have the ground plane. Perhaps you can leave the ground plane on the ground plane, but sometimes it's quite good to have, like with normal cabinets, you sometimes have the floor slightly raised. So we can do that. We can again move the ground plane here, the ground board. We do again another move. And we do this in the Z direction. Let's put a slider in, let's say 20 mil. And now we make this invisible. All I want is this your ground board. So, and now we have all our parts. Yeah? And it's quite good to sometimes give it different colors. And you can do that with a customs preview. And we can give it a color swatch. And if you double click on the color, you get a whatever. You can pick whatever color you want. Why don't we do this yellow? We plug this in and we do the same. Basically what we can do is we just copy and paste that block and we stick our ground plane in here, but we want to then change the color. We come on. So whenever you plug, you can replace one by either right clicking and disconnecting, or you just plug in something else. If you press your shift key down, you can also put more wires in. Yeah. So I could, all these wires I could actually just plug in straight in here, but I prefer to use the merge battery because then you can have a better overview about the chain of your command, you know, where the data is coming from. So I don't like to stick two cables in one battery. You can do it, sometimes it's convenient, but I prefer the merge battery here. Yeah. So I disconnect this one and I give it a different color. Looks all right. Okay, now, and let's save this. So now we've got a complete box parameterized. We can change it in any way, shape, or form we want, and all the other parameters go with it, right? If we replace all the panels that say 3 with a slider, we could also change the thickness of the material. So this is a, you know, quite a powerful tool to enable you to just be far more flexible in your designs, whether you work with meshes or with planes or with, you know, even if you just work in 2D with lines. Grasshopper is a very, very powerful tool. It just gives you, you know, if I give you an assignment, design me 20 boxes, yeah, of various scales. This is now so easy, yeah. Whereas imagine you would have to do this 20 times in the Rhino environment, you know, then it starts to really suck, yeah. So I urge you, for once you get used to it, working with Grasshopper within the Rhino environment, you will start to replace certain operations with Grasshopper. It's just inevitable once you get the grasp of it, because when I go now to Rhino, I always switch from Rhino to Grasshopper, but I would say 90% of the work is done in Grasshopper. And then I just do the end bit when I kind of need to figure out the mesh, or I just do that at the very end. If I want to, for example, send something to a 3D printer, or I need to send something to a factory and they want to have a DXF, it's the end part that then is done in Rhino. The entire design work, I do everything on Grasshopper. Yeah, and again, as you know, I'm working quite heavily on the robots. Everything on the robots, with all the robotic tools we have, is designed in Grasshopper. Yeah. So what I'm going to do is now I stop the recording, and I hope I can